All right, day 7. I just finished reading through the instructions for part 1. I'm honestly very confused. You're sort of confused. This is my puzzle input. Look how long it is. My goodness. The big thing that I don't get is what the heck is the weight? So let me talk about it briefly. So we have all this data that's sort of flat, and it represents a tree structure of data, but we need to construct the tree based on this flat info. So for example, we know that QNIEM has these children, including UHS, and then if we search for it, UHS has yet more children, and then that doesn't have children. So like this is the end of a tree. So our first task is to figure out what is the bottom of the tree. I kind of want to take a cheating solution here. So in our small example, the bottom of the tree is TKNK, and we see that TKNK has children, and so do UGML, PADX, and FWFT. But of all of the things that have children, TKNK is the only one that doesn't appear as a child as well. So I have no idea what weight is, but I feel like we can probably determine the bottom of our tree by just looking through all of the nodes, figuring out which ones have children but no parent. And then that'll be a way to determine it. So I'm tempted to just do that quick solution, but I think we're going to need to do a bigger thing in... I was sort of playing around trying to figure out if the weight was based on the value of the characters in the alphabet, the index in the alphabet, but it doesn't seem like it. I was just doing a quick Ruby script. Anyway, I think I'm going to start with that quick version for part 1, and then we'll see for part 2. Maybe it'll give more info about what the weight means and we'll need to do something better. Let's jump in. Okay. Carga, new, bin, day 7, star 1. Okay. And, yeah. So let's copy this into example input. Tempted to switch to my quieter keyboard because I was listening to one of these. I have 3 keyboards at least. Okay, hold on. Apologies for the digression. I might remember to edit this out. Okay. Great. Okay. So this should be even quieter, which is probably for the best. All right. So let input equals include stir example input, and then I guess instead of here we'll just print out the root for input, and then this will be puzzle input, and that can come from here. Whoa. Right. Important step. Oh wait, didn't I? Oh yeah. Caps lock is control. Cool. So cargo run. All right. Okay, well, that's sort of interesting. I guess I'm probably gonna have some lifetime. Oh. Nice. Cool, cool. All right. I'm sort of surprised that we're allowed to do this, but whatever, I guess. Because, like, this is, well, whatever. Whew. All right. So I think we want to do something like input dot lines, and then here we should do something like program from line, and then we can do dot okay, find program and we'll say program dot is parent and not program is child, and then we'll return the program's name. All right, so we'll need to have a program struct with a name. Oh, let's see if we can. Impl program from line input returns the program. Okay, so I'm kind of stubbing out some of this stuff, but let's try to run it. Yeah, we need a lifetime parameter. Okay. What does that look like? Is it like that? And then like that? No, that's not right. Undeclared lifetime. Maybe it goes there. Alright, then we need it here too. Also here. Hey, nice. Alright, so I totally don't know what I'm doing with lifetimes, but I did a couple months ago, and I forgot. Okay, so let's improve this. So we're gonna have a line of input that's gonna look like this, and I almost want to reach for a regular expression. That might be a fool's mistake. But that is sort of a tool that I'm comfortable with. So yeah, why not? Okay. And then, yep. All right. Lazy static, that's neat. I haven't used that before. I'm not going to worry about it yet. This is about optimization for, like, actually constructing a regex can be kind of expensive. But we're not going to worry about that yet. Because, like, worst case scenario, we are making it 1,083 times. That's not that bad. Okay. It would be good to do it lazily, but whatever. Okay, so an example. Cool. So what does it look like? So we expect it to look like word characters. And is it always going to be 4, or can it be more than 4? It can be more than 4. So let's just hit plus, because there'll be repeating, and a space, and then a parenthesis literal, and a close parenthesis literal, and digits repeating, and then that could be the end of it. So let's say this whole parenthetical group is not captured, and this means not captured, and this means optional. It may or may not exist, but if it does exist, it'll look like this. And then, I think for this last capture group, I'm just going to say word characters, comma, and space repeating. And I think that is a legitimate regex. It does look pretty hairy, but let's try to use it. So And then the name should be caps dot get one unwrap, and we can just do print line caps just to print out what do our captures look like. All right, cargo test, no capture. Okay. So, okay, so we need to do as stir if we want to get the stir out of there. Okay. Great. So, so for the line PBGA 66, why do we only get A? What did I do wrong? Oh, okay, we want the plus to be inside of the parentheses there. Okay. Cool. All right. So there we go. I think that was actually pretty good. So the problem is that the very first program is a parent and it's not a child because we didn't actually implement these. So what if we say children children is going to be oh. Okay, sure, whatever. So all right, so I think we want to do children is going to be let children equals match caps dot get one or two. So if there is a match, then we want to do sum of cap as stir, and if there's none, we'll just say none. So then children is going to be option of stir. I think that might be right. And let's see if that compiles. Cool. So then is parent is just going to be self dot children is some. Okay. So nice. So that means that we then parsed more of the programs, and we got to the first one that has children, which is FWFT. So for children it has this string, but that's not actually the right one. So we need to also implement isChild, but I think to implement isChild is actually going to be a little bit more complicated. So maybe we should filter for the parents. And then of the parents, we should find all right. So filter the programs for the parents, and then find among them So check each parent to see programs dot find inner program. Okay. Has child program. Okay. So instead of isChild, we can do this one. So we can say has child self other program bool, and right, so we can say self dot children match self dot children. Oh, you know what? I think we should do a little more work up here. So in the case where we have this, I think we should parse it out a little bit. Right, so we can say let regex2 equals regex new, and this can be all of this business. So what we should now be able to do is re2 dot captures cap as stir unwrap get one dot split on a comma space, and I guess we need to unwrap and then as stir that before splitting. And that's a little bit awkward, but the nice thing, and I guess then we can collect, and then we'll say this is an option of a vec of strings. So then, all the way down here, we can more ergonomically say self.children match self.children some children contains other program.name, and then none can just be false. So like make the thing up top more awkward to make the thing down here more ergonomic. See if I did any of that right. Oh, none of it. Oh yeah, that doesn't look good. Okay. Okay. Woof. Woof, woof, woof. Oh god. To prevent move use. Okay. Cannot borrow mutably. Oh my god. What's happening? So consider changing this to mute program. So 47. Cannot borrow mutably. Why are we borrowing mutably on 53? I don't think we are. Does find need to borrow mutably? It does, but why? Guess I can make it mutable. Alright, value captured here after move. Value moved on 51. Huh, okay. Construct is never used program. Whoa. Oh yeah, I guess that makes sense. Okay. Let's just see if we're getting something that looks right. Derive, debug. Cargo test, no capture. Why is it not printing? Oh, I guess this might be lazy in that it doesn't actually need to run yet, because we never collected it or anything. Okay. I want that. Mm-hmm. Mm-hmm. Okay, well, now we're getting a little closer. So the problem, I guess, is somewhere in this line. So we want to... so first we filter for the parents, and then I guess we can say something like parent program, and then we want to say okay, so there isn't any. So if we can find any program where the children contain, where it has the child of the parent program, right? So programs.any, any program has child parent program. I want this to equal false. But we're not going to be able to do this. So the value is moved there. And then captured here after move. Alright, well, we don't need to be so fancy, right? We can just be like, for program in programs, if program is parent, and if then return program dot name. Isn't this basically the same? Oh, well, that's not good. guess we could always just do, or so we can assert that, and then in our main function, we can just unwrap because we can feel confident. So here we reference parent program, but we just mean program now. Oh boy. Oh boy. Okay. Did you mean programs on 54? Oh, shoot, yeah. Well, guess we could always just build it again. All right, great. So I thought we were doing a quick hacky solution, but it ended up taking longer. And who knows if we're even about to get it right. Or how long this will take to run. Jeez. Cool. Cool, cool, cool. I can comment out that guy. And that guy. It'll run way faster. But still, who knows how long. Maybe the lazy static thing is a good idea. Yeah, I think a lot of the time is probably spent in these regex compilations. So let's actually just try to use this and see what it gives us. Seems like a really cool solution. So then we can do all caps RE and then lazy static. I guess we are going to need to explicitly depend on this. Huh. That was incredibly quick. Okay. Let's just time that. Target release day. Yeah, 0.2 seconds. Let's see if we actually got it right. Great. Okay, so we learned something about Rust there, which is lazy static rate is very cool. Wow, I love that. Okay. And compiling regular expressions is slow. And when you do a really brute force solution where you compile them over and over and over, then that's kind of crappy. But great. So part 2, I'm guessing, is going to make us work harder. Let's take a look. Program explains situation. They can't get down. Alright, I'm actually going to pause and read this and get a drink of water. Hello, okay. So let's jump into part 2. Where we left off was that we did a kind of cheating solution for part 1, where we didn't really build the tree like we were supposed to, but we really, I think, are going to have to build a tree for part 2. We now know what the deal is with the weight. The weight was something that we didn't really need for part 1, but we're going to need to care about it for part 2. So our task now for part 2 is that we need to actually build the tree, and then what? Then determine where the tree is not balanced properly, and then identify how off it is, and then I think that'll be the answer. So like here TKNK has a weight of 41, is that right? UG, and that's how much this like node weighs. But it has 3 children, and it's 3 children, UGML, PADX, and FWFT. They all need to have the same weight for it to be considered balanced. So let's see, UGML. And the weight is determined by adding the weight of the node plus the weight of all of its children nodes all the way down, however far it goes. So UGML is 68 plus GYXO is 61 plus EBII is whatever, 61, JPTL, 61. So this part's balanced. So 61 times 3 plus UGML is 68, so it's 251. Anyway, they kind of go into it in the detail here. So this one, this branch of the tree comes out to 251, but the other two come out to 243. And so the problem is that the UGML branch is too heavy, and yeah. So even though the nodes above UGML are balanced, so these are each the same, UGML is too heavy. It needs to be 8 lighter for it stacked to weigh the same as its siblings. So its siblings are each 243. So I think our plan is to build the whole tree and then identify and kind of explore the tree until we find an imbalanced node, and then figure out how off it is. So I'm just going to copy day 7 star 1 to day 7 star 2. Okay. And this doesn't really matter that much, but I'm just going to update that. Copy over day 7 star 1 to day 7 star 2. This should still be able to run without difficulty. And I did run cargo format and make it commit while I wasn't recording, so the only difference here is that this is now split out over multiple lines because cargo format wanted to make that easier to read. Okay, so our plan: actually build the tree, walk the tree until we find an imbalanced parent, return return the difference, the amount it is off from being balanced. Okay, so I think we, one thing we could do here is just say for our test, amount off should be 8, right? Or I guess actually we need to know the actual weight. What would its weight need to be? Of imbalanced node. This can be sum 60. And I guess we can say that that'll have it'll take in the input string and return a I guess a U32 is fine. Okay. So let's see if that runs. It does not. I guess I need a semicolon. You don't need a semicolon on the last expression, but I guess we might as well well, let's just have this return actual 60 instead of an option of 60. Okay. And for our main function, we can print out what do we want? Proper weight. So when we do cargo run release, it should oh, I guess we aren't going to need to unwrap in this case if we just return an actual number. Okay, so we get 60. No problem. All right, so we are hopefully going to be able to reuse some of this code. Not all of it. So the way to build the actual tree that I'm thinking is that, so let's first get the root, right? I think we should get the root and let root name equals the root for the input dot unwrap, and I think we want to get the pool of all the nodes, so that'll be something like input lines map line program from line. And I guess we can collect this into a vector of programs. And we don't actually want our test to pass, so I'm just going to change that so it doesn't. And eventually we want it to have the correct implementation. So I think what we want to do is we want the ability to, what if we have something like this? Let's say like type program pool equals vac of program, and are we going to be able to do this? This feels like it would be cool if we could have, so I think this is called a type alias, and then say like I just want to like add a function, like add an instance method to a vac of programs and have it be like find by name. Which would return a program and remove it from the pool. mutable reference to self, and then name stir. Find by name and remove from pool, right? So what I would like to be able to do is say like let mute tree equals pool dot find by name root name, and then let's print out the tree. So we should be able to do, let's pull up the vec docs again. Okay, great. So we're going to need to look up the index. Look up the value by index and then remove it. Okay. Great. Okay, great. So we can do self dot let index equals self dot iter dot position program dot name equal name, and then do self dot remove at index, right? So I guess we can do unwrap here because we just want to feel confident that that'll happen. And if we go back to the vec docs, great. Okay. I think that looks good. So let's see if that works. Expected lifetime parameter. Really? I didn't expect that. Can I just put one? I cannot. Well, what would it look like to put a lifetime parameter? Alright, well, how about this? How about I just say how about we just say that down here we have, let's not be fancy, let's just have a vec of programs, and then we can say find by name, and then we'll pass it in the pool. So it doesn't need to be an instance method. It can be a global function. So it should take in something like pool, which is going to be mutable reference to a vec of programs, and let's see if that works. Whoa, it really doesn't. Oh, well, this shouldn't be self now. This should be pool. And 87. Oh, okay. Expected lifetime parameter. Oh, okay. I think I see what it's getting at. It's like, where does program come from? I think we want to say something like this. That didn't work. Expected type. Crap. Rust lifetime expected lifetime guess I can always do what kind of lifetime framework I have to use here. Undeclared lifetime. Okay, I think we're getting closer. Okay. I need to declare it somewhere. Or maybe I declare it... I don't know where to declare it. Alright, well I declared it, now we have a different error. So types differ immutability. So now 196. I think I just need to say that I'm giving an immutable reference to pool. Alright, we are in business. I can't believe that worked. Okay, so where's the thing that we print out? Okay, cool. So we print out tk and k, which we know to be the root. So we found the root, and then I think what we want to do is something like tree dot enrich pool. And I'll tell you what I mean by that. So we want to what it currently has is children, which I think we want to rename. So I call this children names. And what we want to do is we want to enrich the program by converting its children names into actual children. Okay. KKK, not the hate group. Sorry for even saying that. All right, so then, whoa, children. Okay, so now we want children names. How we doing? Okay. So I think what we want to do is actually add now children, which is going to be an optional vec of programs. So you may actually have more programs as part of your cell. So that's like a recursive definition. Okay. Okay, so we need a lifetime parameter on this new thing, which is sort of fair. Although, to be completely honest, I just keep saying tick A, and you gotta think at some point that that we might need something else, but I don't know what that would be. Okay, we're still recording, good. So that didn't work actually. So in this other one, okay, maybe we need to put it after the program like that, like we did over there. So okay, well, we are in progress here. Okay, so our problem on line 50 is that we are now constructing some children, or constructing a program without giving it any children, but it must have a vector there. So I guess we can do something like this. Like, let's say let children names, and then we can return some vec and here we can do none. And now on 99 we call this enrich method, which does not exist. So let's just give it an empty enrich method for now. And okay, we're supposed to pass in a pool, which is a vec of programs. Borrow of pool occurs here. Can it move out of pool because it is borrowed? Borrow pool occurs here. Enrich. So I think we want to give it a mutable reference to pool. But now it... Alright, so now we are trying to lend it mutably twice, which we can't do because I don't know. Okay, so how do we resolve that? Well, I guess one way we could resolve it, I was thinking that we would remove things from the pool, but we don't actually have to, right? Like, so we can have this be a non-mutable reference to the vector, and then just do pool.iter find and just return it without removing it, right? And then the pool doesn't need to be mutable, and we can just give references to the pool, and then we can lend it more than once. I think that makes sense. Expected to destruct program. Found reference. Okay, so right. What if this just returns a reference? Is that okay? That's not okay. Just keep adding the tech A. Count bar is mutable. So this still needs okay. Okay. Well, okay, how about we actually return it then? Return the actual program. Expected lifetime parameter 92. Right, yeah, let's return the actual program. And then what if we use a star to dereference? Is that going to work? Cannot move out of borrowed content. We could always clone. I think that could work. Expected found reference. Alright, let's return a reference. And then we try to enrich the tree, giving it the pool so it knows so as a reference to the pool. I mean, I guess we could always, again, to sort of brute force it, instead of passing in a pool here, we could pass in input stir, right? And then build the pool over and over, and then we could even combine this to iter, right? So we can do the lines, do the map, do the iter. I guess we probably aren't going to need to iter because it'll already be an iterator. Now we're under 100 characters, which is kind of cool. Okay, this seems kind of reasonable. And then return a reference. Okay, well that's... Well, I kind of like going the brute force way just because it's simpler. So forget about the pool. Let's just then... Okay. We can enrich a tree, giving it the input again. And now... Whew, okay, what is this? Now in the enrich, this now should expect input, which is going to be stir. Pool not found in the scope. Find by name. Just give it the input instead of the pool. Input.lines. Wow, a lot of output here. So a lot of notes, but and the notes are probably helpful, but I'm not going to read them. I'm just going to look at the red line. Okay. Well, this is probably just too much on one line. So input.lines.map, line program from line, find, okay. Well, what if we get rid of the lifetime business? Okay, well, I guess we need it. But why do we need it? That's what I don't get. We'll put that back. So how do we, I want to dereference, which I thought we'd do with the star. Yeah, so now we've got the double reference. Okay, well, what if we... Okay. All right, well, the other thing... So the find method explicitly returns a reference, which we don't have to use, right? Like we can just do let index equals okay. Okay, index equals programs dot iter dot position program dot name equal name unwrap, and then just return programs index. Oh boy. Conflicting requirements. I don't understand why we need... Oh, okay. The return type... Oh, okay. The return type contains a borrowed value. Okay, so... Maybe that's the problem, is that the program is constructed from the line, and the line comes from the input. And so the program needs to live... needs the input to live as long as it lives. Cannot move out of indexed content. Oh, all right. Okay. Programs.get index.wrap. Kind of move out of bar context. Yeah, I'm really fighting with it here. Index. What does this mean? I've never seen this before. Cannot move out of indexed content. Rest. What if I clone it? I can't clone it. So we can't clone a program. I wonder if we could if we just derive it. Alright, so we're making progress. I feel like I'm not writing very good code. Let's just let cargo format help us out again. Alright, so it wants to improve that, and that, and that. Okay. Sure. So I think the next thing to do is actually implement enrich, which is going to... Here's what I'm thinking. Eventually, it's going to return nothing. But what I want to do is say something like match self.children names, some children names, then we'll have some behavior, none, then we'll have no behavior, and then we'll say, like, for child name in children names, we can do self or let child equals find by name, right? So we're gonna then pass in input and child name, and this will be mutable, and we will call child.enrich, and then we'll do self.children.push child, right? So I'm hopeful that we can then build the whole tree this way, and I think we can. I don't think we actually need that. Let's see what happens. Okay, that didn't work. Haha. So one issue is that we might not actually have a children. Maybe children should always be a vec. 80. So, oh, we're supposed to pass along the input. Okay. Cannot move out of barred content. So we can use ref children names. I don't really understand what that means. That's something I should learn. Okay, so on 81, cannot move out of barred content. Okay. Well, how about this? How about we just make this one simplification and say that it'll always have a children vec, and that simplifies this a little bit. So we can have this return a vec, and then this can also return a vec, an empty vec. And then 81, we don't need to unwrap anymore. And that didn't actually help. Cannot infer an appropriate lifetime due to conflicting requirements. So 79, trying to pass along the input and child name. Yeah, I can't help but think that this very detailed error message is trying to tell me something. Okay. So, cannot for appropriate lifetime due to conflicting requirements. So, on 79, okay. Well, one thing we can do is And this is sort of less efficient, but we could like, what if we pass an owned string every time? And then everywhere we call find by name, we just need to make an owned string from that stir. And does that help? No. Input does not live long enough in 106. Okay. Yep. Because eventually, I guess the problem is that the children names are all going to be references into a string. So it needs to live long enough. So let's undo all that. Okay, I think that's where we want to be. Okay. So cannot for an appropriate lifetime parameter for lifetime parameter tick A due to conflicting requirements. So where are we? We're passing in input, which is coming from I don't think we can just put an ampersand on it. That would be too helpful. I could always add more more lifetime parameters, right? Like on enrich, we're not annotating crap on here. Maybe that doesn't matter though. I don't think that helped. Alright, so let's read this again. So I'm going to make a fresh terminal so I can scroll all the way to the top. Okay. Cannot infer an appropriate lifetime for lifetime parameter tick A and function called due to conflicting requirements. So let's actually read this. Okay, first the lifetime cannot outlive the anonymous lifetime number 2 defined in the method body at 75. So we didn't explicitly declare a lifetime on enrich. But there is one, it's just inferred or anonymous. So that reference does not outlive borrowed content, but the lifetime must be valid for lifetime tick A. So that expression is assignable. So here on 81, we okay. Yeah. So there. Well, I guess one way we could do this is instead of enriching passing along the input, so we could say that we don't pass along the input, but rather when we okay, from line input. We could let like what if every program knew about the input, right? So then it could just get the input off of itself. I mean, it's duplicating the input throughout in every program, which is so noisy and crappy. But what does that get us? It gets us this. So it gets us this. We could just pass himself that input each time. So we have a couple problems here. So anywhere we call from line, we need to pass in the input again. Wait, does it go input line or line input? Line input. And then, okay, line stir, input stir. And here we want to just look at the line. And we're missing a lifetime parameter still on 24. Did I get rid of that? I feel like I had that before. Oh, I guess we need it now that there's two inputs. So we want to say that it has a reference to, I think both of these should be tick A because it has stuff from both. Or I guess we could oh boy. I might have made this twice as complicated. Oh boy. I don't think I did good. So this one is from tick B. So everything comes from the line, which is tick A, and then the raw input comes from tick B, which is the raw input. Lifetime tick A already in scope on 24. So maybe I don't need to put that there. Expected 2 lifetime parameters on 107. Okay. Input tick A, name, okay. Alright, and then here, that needs a tick B as well. Okay. Oh my god. I don't love what I'm doing here. Oh, I made it worse. I think I made it worse. So on 81, we do a find by name, passing in the input and the. Oh boy. All right, I'm going to pause for a minute and look at Twitter because I'm getting a little bit nervous. Okay, picking up, working my way through Day 7, Scar 2. Took a break, watched Curb Your Enthusiasm, drank some juice, ate some leftover pizza, which arguably I shouldn't be eating because I had a surgery a couple days ago and I'm supposed to be on soft foods, but I'm not having the crust. It could be worse. I had an idea for one way to improve this. I'm not sure if it actually does, but I'm thinking about using constants for the input string. That might be good. So I'm not sure if that will work, but I think that's what I'm going to try. So I'm going to say const puzzle input. Okay. I guess maybe they should be capitalized. Puzzle input static stir equals include stir puzzle input.txt, and then const example input I think that makes sense. Maybe we don't need to do that. So, okay, so then, instead of input, we can say puzzle input, and then in our test, we can say example input. Is this going to help? Well, probably not, but let's see if we can confirm what's going on. So input is not found in the scope. Oh, okay, so let's also have that be example input. And, yeah. So, right, so we went down this road of introducing, having the program also own the input. I want to get rid of that. It might take a lot of deleting to get rid of that, but I think I want to get rid of that. So I'm just gonna get rid of all of the bticks. We'll see how much pain this leads to. Just sort of scrolling till we see bticks. Okay. Try again. Alright, so 57. Now we no longer want to store the input on the program. Likewise, 82. Okay. So we're going to pass through the input to enrich. So enrich. Alright, yeah, so we do pass in input. Then we pass it along there. Cargo test. Can I for an appropriate lifetime parameter for lifetime parameter A. On line 81. So find by name. Okay. I guess this is where I'm hopeful that we're going to have some payoff, where everything should be coming from a static string now. Hopefully. Oof. That's a reserved lifetime name. Okay. Let me undo all of that then. Okay, so we can offer an appropriate lifetime for lifetime parameter A in function call on 81. If we got rid of that, I think it would make us add it again. Lifetime of reference. Right, so we pass in the static string to this proper wait method, pass along the root name, pass it along to tree, pass it along to enrich. We want the ampersand. I notice we have it in one but not the other. Huh. Okay. Cannot infer. Yeah, lifetimes are so confusing. Cannot infer an appropriate lifetime for lifetime parameter take A and function call due to conflicting requirements. I was hoping that having it be a static thing would help, but maybe it doesn't. Or maybe this isn't actually static, so maybe we should try to actually use statics here. Wonder if that'll help. Static name. Right. I was gonna say, oh yeah, we're back to that error. Okay. Whew. Okay. Cannot for an appropriate lifetime for lifetime parameter A. And the find by name method returns a cloned program anyway. But Find by name input. Same problem. Okay. So on the definition of here, I kind of feel like we should be able to do this, because all of this is just referencing into I don't really want to have anything like this. Find by NAM. Oh. Okay. Unexpected lifetime parameter 21. Alright, well, we can get rid of that. Test. What? This is very different. Cannot find an appropriate lifetime for parameter t in function call. So on line 34 now we have a lifetime issue? Oh, maybe that actually makes sense. Because this is going to now be referencing into the line, which how can we resolve this? RE to capture is kind of inappropriate. Rest regis. What is the type here? When we this is going to be an option of captures. Okay, so I guess this is where T comes from. This seems to okay. Well, what if we do that? I suppose that didn't help at all. Huh. So eventually we are going to use the caps. That didn't work. Okay. So what am I talking about here? Same issue. Okay. So we could map over these, right, and do something like name to owned, collect. So what that would mean is that then the names would be a vec of Yeah, I mean, we could do that. We go down that road. Make the children names be owned strings. And then anywhere we are using children names, right? We can then do a to owned there. A reference there. But that didn't help at all. So let's just back that out now. I feel like I'm just flailing, trying things. Wait, undo. Okay. There we go. I think that's where we want to undo to. So, So instead of assigning to caps, because that seems to be problematic, let's do let children names equal re.captures line match some caps that'll have some behavior, and then none will have none behavior, and then like caps equals. Oh, I guess we. So we want to unwrap and then get to, and then match on that. So if there is a cap, then we'll do one thing, which is to return some of this other thing. Okay. And then children is always going to just be an empty vec. And we don't even need to assign this to a variable. Okay. So by doing this all in one statement, are we going to avoid this lifetime issue? Oh, well, instead we get a syntax error. Okay. doing the capture 2 times, which can't be correct. Okay. Captures. And I guess we need to unwrap. Okay. And we're probably just back to where we were before. Yeah, we really are. And then does that help? So if we make it an owned string and then we say this is just going to be a string. Oh my god, okay. So now we have other issues, but the lifetime issue didn't even go away. Oh god, I'm flailing. Okay. Well, let's just keep flailing until something works. Whoa. Okay, 121. Now 111. Find by name. Oh, we can pass a reference to find by name. And on 64, children names. Yeah, I mean, I guess we did experiment with this earlier. What if this just all was, what if we just use regular strings for everything? Huh. That's funny. So we finally compiled. And we are printing out our tree. Does it look correct? It's not pretty printed the same way as the other one, but maybe we're getting closer. Alright, so I'm not very happy. Let's also cargo format, which is going to fix our indentation. Sure. Reload to get those changes. Alright, so I'm really not happy with how we're doing so far. And what is this? Oh, in the from line 25, we never reference the input in the from line method, which is kind of interesting. I guess we don't need it anymore. So we can update all of those places to only pass in the line. Alright. Yeah, I mean, as far as I can tell, this is good. I think we also want to parse out the weight. So from the line, we want to get the weight, which is going to be this numeric value. So that should be I guess we're not capturing it yet, so we want to add a parentheses to make it a capture group, which means this is going to become get3, and we can do let weight wrap that wrap. Now I know we're using the regex 3 times. We should really optimize this, but I just want to get it working and then probably never think about it again. Aster, and then parse I32 unwrap. So then we can say wait, don't tell me. That didn't work. Oh, I spelled unwrap wrong. Imagine actually like building a compiler that understood all this nonsense. Oh, invalid digit. That's interesting. So what do we do wrong? I guess we should let's just put like 32 and then print line weight. Just see what kind of weights we're getting. Oh, we're getting the closing parenthesis. We don't want that. So let's just revisit our regex. Okay. Oh yeah. Alright, now those look better. Yeah. Alright, so we should now be able to restore this behavior. And then use the actual weight. Alright, so now each program has a weight, which looks like that came through. And so now we do have the tree, and so somewhere we had a plan. Actually build the tree. We're finally done with that part, I think. Then we want to walk the tree until we find an imbalanced child, I guess. So where are we? So in this proper method, once we've done enriching, we want to do something like let imbalanced child equals what do we want to do? We want to find, maybe do something like tree.find imbalance. And then that can be an instance method, find imbalance, self, I32, and that'll return 4 for now. But we want to do something like So if we go back to our example, when we start out with this one, we were at the root. We want to look at our 3 children and ask them, are you balanced? And if a program is balanced, we can ignore it. And if not, we can look at its children. And self.children for child in self.children. If not child dot balanced, then child dot find imbalance. We got recursion. And then eventually we can do panic. Oh my god. So we don't think we'll ever get here, but if we do, then whatever. We'll blow up. Balanced should return a bool, and that should be self.children.len greater than 0 and self.children weights. We want all the children weights to be the same. Is there any clever way to do that? Maybe a fancy iterator method. Oh, for each, that's a thing. Okay. And then if it's not true, we can do children weights dot sort, and then children weights dot first unwrap equal children weights dot last dot unwrap. Okay, seems like one way to do it. All right, so then we're gonna need children weights. Which can return an I32, or maybe a vec of I32s. For self.children.iter.map child.weight collect. So now we need a weight method. And then I think that what this is going to be is the weight of the node plus all of its children's node. So that can be something like self.children.iter.fold. Maybe this should be full weight, because there's also the attribute. So then we'll fold in self.weight, and then we can do child.fullWeight. Okay. So start with the weight of our own program's weight, and then add in the children's weight. All right, so children This shouldn't be children names. This should be children weights. Okay. All right. So balanced. Okay. Child that find imbalance. So we're start the root node, start going through the children, and if the child is not balanced, then we can keep looking. I don't think this is going to come anywhere near compiling. Okay, well. Eventually, I guess we should return eventually we're going to return a usize. Right. Cannot move out of our content. Alright, so a bunch of crap just happened, but we're not sure what. So we want to find that that one of these is not balanced. I think, which one is it going to be? So UGML is not balanced. So we ask TK and K, are you balanced, right? Or no, we start with the children. We say, are you balanced, child? And UGML is going to say no. But we want to keep going until we reach the end, right? So if it's not, balanced, then if child, right, once we reach UGML, it's not balanced because these three are different, then what? We want to keep going. Keep going, but how do we know when to stop? Okay. Okay. So let's just have some debug logging in this case. So we can say print line not balanced because this many children and their weights are so children weights dot len children weights. All right. Well, we don't see our debug output, which is a little surprising. Okay. So it's checking TK/NK for imbalance, and that's the only one it checks. So that's the root. And there should be children, right? Yeah, there are children. So let's say print line. We can say self.name, child.name. So that's not true. UGML is not balanced. What the heck? So maybe we need a test for this. Self.children weight, self.children.iter. Okay, so okay, that didn't work. Okay, this needs debug output. Alright, so we are actually getting closer. So checking TK/NK for imbalance. UGML's children weights are 61, 61, 61. That's true. And oh, okay. So that does look correct. Huh. Okay, so maybe the problem is that we don't check TK/NK for imbalance. Right, so we focus on the children. So I guess we need to actually check if okay. Okay. Self.balanced. wait, what am I talking about? So we need to determine. Hmm. Okay, this whole thing is screwed. Okay, let's just say print line. Right, so we can say self.name, self.balanced. And what do we get? Where is it? Okay, TK and K balanced false. Great. Because why? So the children weights are not the same. Not balanced because there are 3 children and their weights are not the same. Okay, that seems good. But we need to keep looking. We need to walk the tree. So we need to like determine which is the branch to go down. Right. Okay. Bring it back on the screen. So okay, so we know we are not balanced, which makes sense. But now what, right? So, okay. So the problem is that one of my children is a different weight than my other children. So that's the one we want to keep looking at. I'm just gonna copy this or move this. Okay. Okay. And So now we need to determine which child. Okay. Which one's different, right? How do we determine which one's different? I'm gonna just use I32s. Okay, so if it's not balanced, then we should cargo test, cargo format, reload, cargo format, saving my bacon again. Okay. I feel like kind of inappropriate weighing children now that I think about it. That's so stupid. Okay. I guess we can do like a hash map of the children and the weights to determine like maybe the names to the weights to determine which one is different. All right, yeah, we can do that. Let weights. Or maybe that should be here. We can say this is going to be a standard collections hash map of strings to I32s, right? Let mute ret equals hash map new standard collections hash map new, and then for each and then we'll return the ret. So then we can say ret.insert child.name child.fullweight. Then we'll return that. And children weights. And let's just comment this out for now. Cargo test, not found in the scope. Okay. Let children weights equals self.children weights. Guess I lost that. Try adding a semicolon. What? Try adding a semicolon. Okay. Cannot move out of barred content. Content 109. Throw a clone on it. Alright, great. So alright, cool. So now we're printing out the children weights here. 251, 243, 243. So now we can determine which child name has the let's go to the hash map docs. We want to see is empty. Okay. Cool. Okay. So, yeah. I'm going to pause briefly. Okay, picking up where I left off, I'm starting to feel a frenzy set in where I've been working on this so long that I'll either survive it or not. But I'm realizing that we didn't actually do the hash map the way that I wanted. We're not getting anything out of it. What we have are a mapping of the name of the node to the full weight of the node. What we really want is the occurrences, right? We want to know how many times the weights have occurred. So we can say instead ret dot entry child dot full weight let value, I guess, or insert 0, right? And then do star value plus equal 1. So the thing is going to be rather a mapping of weights to occurrences. They can both be I32s. But then I think we also are going to want to, so maybe we'll call this like occurrences frequency. But then I think we're also going to want that other thing of a mapping of the name to the weight. So I think we should also have let mute mapping, and then that can be an empty vector, and then we'll do mapping push, and then a tuple of child.name to let full weight equals child.full weight, and because I think we're also going to want to look that up, and then we should return both. So then the return value here will be a tuple, and then the second item in the tuple will be a vector of strings. So let's clone the name. So then when we call this, we can say, I guess, occurrences frequency mapping, and then I guess we can print out both. Well, update occurrences frequency. Yeah, sure. And then I guess we can print out actual values. And then I guess let's just comment this for now. What? What are you talking about? The return value should be a tuple with the hash map and the vec. So I'm trying to destructure. I guess we can do let children weights equal self.children weights, and then we can do .0 and .1 and avoid the destructuring. That didn't help. Okay. No, yeah, let's. Yeah, this looks fine. Self.children weights. Expected string found tuple. Oh, we didn't save. I've had on the scope 443. Oh, yeah, we want this to be commented still. What? Expected struct found tuple. Wow. Oh, okay. I think I see what's going on. So, yeah, so this should be a vec of tuples of strings and I32s. Okay, great. So now what do we get? So, I think this looks good, sort of. Mapping. Okay, we just didn't print out the mapping. Yep. Alright, so if we need to look up the, so we can use this to determine which is the incorrect one. So whatever is the key that has the lowest value is the one we need to explore further, and then from there we can go to the other thing to see, okay, which is the one that has that incorrect value, and that'll take us to UGML. Whew, I do think we're making progress, but very slowly. Alright, so if not, occurrences frequency is empty. Let aberrant value equals, and we can go into the occurrences frequency to find the aberrant value. Or I guess we can't assume that there is an aberrant value. So we can do let, we want to look at the frequencies keys. Occurrences frequency dot keys dot collect. Let's see if we can do that. Okay, so let's say let values, which is going to be a vec of I32s. make it mutable. If, okay, then we can do values.sort. Then we can say if values.first unwrap not equal values.last.unwrap, then we are imbalanced, baby. Okay. And let aberrant value equal, I guess we can go to, here we are with the hash map docs, and we can do an iterator over, so this is a hash map iter, nice. And there should be a min by, right? So we can say let aberrant value equals occurrences frequency dot iter dot min by kv v dot unwrap. And then we should have the key value pair, and then we want the key, right, which is going to be the dot zero, and then none of this is going to work, by the way. I'm like kind of delusional right now. Like I think I would have finished this a long time ago in Ruby, but I'm like powering through. All right, so now what? Now we what do we want to do now? Now we want to go to the mapping. Let aberrant name equal mapping dot iter dot find mapping item dot zero, or no, dot one equal aberrant value, and then dot unwrap dot zero. So we can say aberrant value and aberrant name, and pass in aberrant value and aberrant name. And I'm not spelling these in a consistent way. Yeah, this doesn't work. Alright, so one thing I guess is that we do it like this, so that's different. Expected enum. Oh. X, Y. Maybe we're supposed to do. What is X and Y? These should be key value pairs, right? So maybe x.1 dot compare y.1. Here we do last, but that needs to be a method. On line 143, we reference aberrant. Oh, this should be aberrant value. And okay. We have a mismatch type on 143, which can probably be fixed by throwing an ampersand on it. Nope. ampersand on that one. Sure. 137. Alright, we're trying to collect the keys. Well, maybe that's fine then. Can it move out of borrowed content? Consider using a reference instead. Alright, yeah, I'll consider it. Great, so we compiled, and I think this looks correct actually. Aberrant value 251, aberrant name UGML. So now what? I think now that we know what the name is, we need to get recursive, right? We need to grab the child with the aberrant name, and then how about this? How about we have this function return an option, right? And then find imbalance. And then maybe here we unwrap it, because eventually we expect it to return something. But in our recursive context, we can we don't have to unwrap it. So what we can do now is we can say we also want a normal value, right? So maybe get a normal value and call that the max by. Aberrant name, normal value, normal value. See if that compiles. Okay, normal value 243. So the next thing is that we should then find the child with the aberrant name. Right, so let child equal self.children.find child.name equal aberrant name. So if let sum diff equals child dot find imbalance. Return some diff. Huh. I don't think that did anything. What am I trying to do here? I want to say recurse if the okay. I'm imbalanced. Okay. I'm really struggling here. Oh, maybe I should take a Tylenol. Okay. If let some diff equals child defined balance, then what? What? Can't compare. Yeah. Okay, so that worked ish. So what am I doing here? So we're finding the child, and then we want to if the child itself is we basically want to say if child is balanced, or if the child itself is balanced, then we don't want to touch it, right? So if the child is balanced, return this diff. Otherwise, return the diff between the normal value, or we don't want the diff, right? We want return the proper value by diffing self.weight. Okay, wait. By doing, I think what it is self.weight plus, and then this is normal value. Come on, don't rap on me. Or maybe do rap, actually. Normal value minus aberrant value, right? So we want to offset the current node's weight by, so if the aberrant branch is balanced, return the proper value. If it's not balanced, ask the child to find imbalance. Okay, I think that looks right. So we need a way to ask it if child dot balanced, right? Then we will do child dot find imbalance, and so I guess actually this option business is not what we're going to do. So let's just say I32. And okay, so how do we find out if the child is balanced? And, or wait, what do we do here? All right, so here we want to do self.weight plus normal value minus aberrant value. Hopefully the plus and minuses are correct there. So base case, this is our base case. And then this is our recursion case. Okay, so to determine if the child is balanced, we I think we should add a balanced method, and then we can use it. Let's just do duplication. I think I'm enjoying having duplication. So, what does that mean? It means we can, let's get rid of this. So child occurrences frequency, child mapping equals child.children's weight. And then we can say child occurrences frequency is empty, or let child is balanced equal, okay. True. And then in the else case, we need to check the next thing, which is, okay. Oh god, what did I do? Okay. So let mute child. I'm really loving my lifestyle right now, where I'm kind of just doing whatever. Child values dot sort, child values dot first, unwrap not equal, child values dot last dot unwrap, or I guess equal. All right, this could be it. Nope. Oh god. All right, so on 140. Okay, I guess the issue here is that there's a chance that find will return an option or none, but we don't care. We assume it'll always return something. Oh gosh. Okay. 194. We changed our minds. So this doesn't need to be an unwrap. And we expected a unit, but we found an I-32 on 156. So this is the I don't know why you expected a unit, but I guess we can say return. Why are we expecting a unit still? Okay, we can say return and then semicolon. What? Why? It's still the same thing. 127. Oh, well maybe that's the issue, is that we don't have an else case here. We can just panic. So we ran and we got 33. That's funny. So we expected to get 60, but we got 33. Maybe the problem is that we didn't. So we have child mapping. That's not a problem. Alright, so we don't expect that this is the correct answer, but we do have an answer. But let's get our test passing first. We were very close. Okay, so how the hell did we get 33? So let's have some print lining here. Self.weight. Self.name. Returning via self.weight plus self.normal value minus self.aberrant value. I didn't do that right. Okay. Okay, so returning via TKNK. So self.weight 41 plus self.normal value 243. So this is how we got 33. We did 41 plus 243 minus 251. Okay, that makes sense. So I guess we don't want to do self.weight. We want to do child.weight. Let's try that. Because we have a child, right? So what if we do child.weight? Now our test passes. So what are the odds that this actually works? I think they're low because this code is garbage, but let's find out. All right. I don't know what to say. I don't like this code. It's also cargo formatted. We can't cargo format it because our lines are getting too long. It says sorry. Oh god, it's so cute. Okay. Maybe that's because of this line. Probably it is. So we can get rid of this. Alright, so add day 7 star 2 solution. This is the, I basically just kept using clone and ampersands until things worked. There is a ton of duplication. I am both proud and not proud of this code. Okay, cool. Thanks for watching. This is the longest one yet, and I'm truly proud.